Alright, good afternoon guys. So, sorry for the super old school video, but wanted to keep you guys moving along here with our target on solving quadratics. So that's really kind of why we have the letters SQ for this particular chapter. We've solved things before, we've solved absolute values, but now we're dealing with things that are going to be x squared in their work. And so that's why, if you kind of look at the structure of this problem, we have x inside of a group, and you'll notice we have a little squared up there. And getting rid of that is kind of the problem. There's some tips and tricks that we talked about yesterday, but we'll see with our problems here today, there's kind of a groove and a rhythm that you find yourself in. So first things first, if you're looking at this problem, we'll need to work backwards through PEMDAS. And you got to remember that is when we solve. If we simplify, we follow that order. So I made the silly word up yesterday of SADMEP. And in this case, adding 36 is going to be the first thing we need to do. That takes care of adding and subtracting. So if I add 36, I need to add 36 to the other side as well. 0 plus 36 makes 36. And now we'll write the rest of our problem out. We have 3 in this group squared. Okay? After that, you want to be careful. Never distribute, and the reason is because this exponent is the person who controls that whole group. And in order to get rid of the 3 in front, we're going to divide by 3, and we have to keep things all balanced out and do it on both sides. So dividing by 3's cancel, so that's like karate chopping the problem, and they're gone. You'll have just x minus 2, so a little bit less stuff. And then 36 divided by 3, I believe, makes 12. Now at this point, I don't know if you're running out of room on your notes, but we are reaching the critical step. And this is where we have to go ahead and square root the right and square root the left. That is ultimately what gets rid of this exponent. So we talked about yesterday, you aren't technically just left with x minus 2. Not a lot of teachers will show this step, but you are left with the absolute value of x minus 2. So this is kind of a big deal, and this is what it takes getting used to, I suppose, in this set of notes. We'll get rid of that here in a second when we branch to the positive and the negative case. But often, kids are going to have a problem with what they wrote on the left. The square root of 12 isn't very nice. You guys know things like the square root of 25 or the square root of 16 or the square root of 100. All of those are pretty perfectly, coordinated numbers. 12, not really. And in geometry, you dealt with that by doing what's called a factor tree. So if we take 12 and divide it into its factors, meaning the numbers that multiply to make 12, you can write 4 times 3, 6 times 2 is another way to break 12 down. You'll notice something here in a second. If we take 4 and break it down, it's 2 times 2. And these are all prime numbers. So they're like the atoms, the little individual building blocks that make up 12. Same thing happens here. You get 3 times 2. And so 12 itself can't help but be made up of a 2, and another 3. It's like the DNA that makes that number. Okay, so what do you do with all this stuff? Well, you pair the numbers that have buddies up. You need 2 of a kind. And then anything that doesn't have a pair, so they're lonely, they don't have any extra friends, I put a square around them because ultimately the people who are individuals will stay inside of the square root, and the people who have a buddy are able to escape and be outside of the square root. All right, if you type this into a calculator, you can kind of start to see that these two things are the same awful amount, which I'll try to show you here. All right, so if I clear all of this out, I had already typed in 2 root 3. You can see 2 root 3, 2 root 3 is 3.464101615, and actually that keeps on going. So that's not even the end of the number. If you just go ahead and type in the square root, which that square root button is conveniently on your squared button, if you put 12 in and press enter, look at the answers. So these are the same, but to a mathematician this tells us more because it shows how that number is created and what it's made up of. So that's why we do 2 root 3 instead of root 12. After this, okay, we're kind of back in this awful predicament of having absolute value bars to deal with. And so you guys know from the previous target that you can split this into a positive and a negative case. Sorry about that. And so all you do is take 2 root 3. Remember, 2 root 3 is this 3.46 amount. And you set it equal to x minus 2. And then you'll have a negative 2 root 3, and that's equal to x minus 2. Whatever is inside just keeps hanging around, and you have a positive of the other side and a negative of the other side. And then this is the last step. And so you're probably saying, like, what the heck? We don't have any room left. But we need to add 2 and add 2. And my question is on the left side of both of these little equations is like, where do I add 2? This is kind of a big question, and it's a critical question. People will often try to add 2 with this number in front, and you don't. This is all a very specific amount. It's that amount, okay, that's on your calculator. What we do is we add it up here in the front, kind of as its own individual. So we will do plus 2, and technically there's a little bit of a space here where we're adding. We will plus 2, and technically there's a little space here where we're subtracting, or that negative sign is taking control. So where do we add 2 in these problems? We add it to the front. And that's kind of a big feature of how we write our answers. Our answers sometimes don't look so great. So with this question, we have all of this work. You can hardly see what we're doing. Okay? 2 got added, and then we had plus 2 root 3. That is what x is equal to, since those are now gone. The other answer will be 2 because we added it to the front, but I need to subtract 2 root 3. That is the other answer. So these are very, very, very specific amounts. If you want to know what these specific amounts are, you just type them in. So 2 plus 2 square root 3. Oops. I guess you don't need the extra parenthesis there. The newer, fancier calculators will just kind of keep things bubbled together. My old calculator that I sometimes have on the board has parentheses, and so you need to include extra parentheses to keep things grouped together. But we have 5.46, and so that is what this top answer is. It's just a number. It's an ugly looking number, but hey, can't be too picky. And then if I go ahead and do the other answer, which I just kind of copied my previous work, you just change it to be a minus sign, to minus 2 root 3, and that will be negative 1.46. These two amounts, if you think about them as decimals, are the only two amounts that I can put in for x and work out all of the algebra and get 0. Anything else, even if it's like 5.5, it doesn't quite work over here, and it's not 0. All right, so that seems like a long process, but as you get used to this, you'll get a little bit faster and a little bit faster. I'm also going to help you out. This is probably one of the last problems where I do the 2 branches. These two things take up, a lot of space. What I will gradually start doing is combining these to be the same answer, 2 plus 2 root 3, but then also 2 minus 2 root 3. And stacking the plus and the minus sign together saves about half the space. Some people also get all worked up that I have equals x at the end. You can put it in the front. It really doesn't matter, but you need to understand that this is 2 solutions, just kind of like how I wrote out both solutions up here. That's all the same thing. All right? Sorry if you ran out of space. I need to give you a little bit more room next year, and so that's something that I kind of have been thinking about. But let's go ahead and let's try number 5. And again, sorry for the old school work here. But 0 equals negative 4. X minus 2 is in a group squared plus 36. And we'll scooch our camera so you guys can actually see it. There we go. First thing, we're going to get rid of that 36. And if I subtract it over on the left and the right, these are gone. And I get negative 36 equals and I have negative 4 times this group of stuff, all being squared. All right, just from the first problem, you note do not distribute. That is a no-no. You get rid of that by dividing. And I like doing that anyway because you get to cancel, and they're gone. Negative 36 divided by negative 4 is positive 9, which is nice that we're dealing with positive whole numbers. Again, that's kind of where we want to be. Not that that's always the case. And so I have x minus 2 with a squared, and this is that critical step. How do we get rid of a squared? We must square root. Now, thankfully for this problem, the square root of 9 is actually pretty nice. 3 times 3 makes 9, so the square root of that is just 3. And then be careful that you don't just write down x minus 2. You have to make sure that you are remembering this is the absolute value of x minus 2. That's kind of the key step. So if you put a star here, this is what you need to really remember. Then, normally we would do positive branch, negative branch. I'm going to show you a different way that combines your work together. It's going to save you, twice as much space. So I will typically get rid of these absolute value bars. We can't get into it until the bars are away. And so scribbling those absolute value bars only is possible because I'm dealing with the positive case and the negative case. But what I'm doing to save some space is I'm putting a plus in front of the 3 for the positive branch, and I will put a minus in front of the 3 for the negative branch. So almost imagine these two branches are going to get smushed together into one big branch of work. So at the moment, it looks like this. Now, the only thing I need to get rid of is this minus 2. It's not hard to do that, but that's where my question from the first problem came in. Where do I do this? And if you remember what we wrote, that has to go in the front. Plus 2 happens in front. People are tempted to add it to the 3, which is not true. You can't just take 3 plus 2 itself and keep the plus and minus. What you're doing, if I have a little bit more room, is saying 2 plus 3 is one of the answers, and then 2 minus 3 is one of the answers. 2 plus 3 is just 5, and then 2 minus 3 would make negative 1. Those two amounts are what balance out this original equation and make it 0 or whatever we wanted in the first place. Okay, so this is going to become a little bit easier as you start to see more of these problems. Feel free, if you need to pause the video, you certainly can do that, but let's hop to number 6. So this says 23 equals 5. We have x plus 3 is a group squared minus 2. So we're going to deal with this minus 2 by adding it. Actually, 23 plus 2 makes 25. So that lines up a little bit better than if we had tried to deal with the 5 first. If you divide by 5, you have to divide this piece by 5 as well, which isn't always the nicest. But now that we're here, we can go ahead and we can cancel out and divide by 5 and divide by 5. So these guys are gone. X plus 3 is a group squared is here, and 25 divided by 5 is 5. Now after this, we're kind of reaching the point where we need to square root, because otherwise we can't just get rid of the 3. It's trapped. And so if we're going to untrap it and free him, we have to do square root of x squared. That leaves us with x plus 3, but you got to remember that it's in absolute value bars. And then this guy, square root of 5, is a little obnoxious. 5's a prime number. If you did this in a calculator, I think it's 2.23, give or take. The decimal probably goes a lot longer than that. So we'll just leave it as the square root of 5. We don't have to write all the decimal places. Looks a little cleaner that way. And then remember, what are we going to do? Well, we're going to get rid of these bars by having a positive and a negative version of this other side. So you put the plus or minus sign over there, and that's how these go away. You could equal a positive version of that or a negative version of that inside. So if I have plus or minus square root 5 equals x plus 3, we just subtract 3. And remember, we have to put that in the front. We do not get to add it to the 5. We do not get to put it in the front side of the square root sign. Those are all mistakes that I want you to avoid. Don't do that. And so finally, I will rewrite it probably a little bit. So it has x equals in front. Kids like to see it that way. The -3 is the one who's leading the way. It's in the front. Then we have our plus or minus sign. Then we have square root of 5. How many answers are in this box? There are two solutions. If you needed to know what they were, you just take your calculator. Sorry if I'm covering things up. And you type that in. Okay, so let me clear out my screen. Be careful on your negatives. You have to use this negative button at the bottom. This is subtracting, which I don't know why those are different to a calculator, but they are. You'll get an issue if you use subtracting. So we'll type in -3. Okay, I'm just following this. Plus, we'll do our square root sign. We'll put 5 in there. We'll press enter. So -0.76, yada, yada, yada. And then if we press, this is a nice little shortcut, second, and then equals, it copies down our most recent prompt or whatever we had typed before. And we just change that plus to a minus and go about our way. And the other answer is -5.23. Had a really good question earlier today. Do we have to write these? No. But it should give you an idea that these are just like two numbers. They're awful numbers. You couldn't probably guess these amounts. And these are the amounts that would perfectly give us 23 in this case. Whatever we want to equal, that is the missing piece that does it. And so that's why the solving process is so important. You can't get these probably without going through these steps. You'd be a genius if you could just guess these and pull them out of thin air. So let's do one more. Okay, and hopefully you're catching on. We'll do number 7. Kids think that number 7 is the worst, which it does have a fraction, so I'm not going to blame you for thinking that. So 20 equals 6 plus 1/2 x squared. Now the first thing you got to deal with is still that 6. I know it's in a different spot, but you get rid of it by adding and subtracting. You move it over to this side. 20 minus 6 is 14, and we still have the 1/2 x squared. And then this is where you have some choices. If we divide by 1/2, that's okay, but dividing by 1/2 doesn't look that friendly. You have fractions over fractions, which is yuck. So what I typically do, instead of dividing by 1/2, is I multiply to cancel out. So if I have a 2 on the bottom, a 2 on the top will cancel that out. And if I have a 1 up here, I need to have a 1 down here. Okay, so I'll change colors so I get the satisfaction of double karate chops. They're gone. Hi-ya! Now here's the deal. You have to multiply by that pink 2 over 1 to keep things balanced, okay? So that way your problem is still true and accurate. 2 divided by 1 is just kind of like saying 2. And if I have 2 times 14, that makes 28. People will screw this up and they'll just divide 14 by 2, and that's not how you really deal with that fraction in the first place. So here we go. 28 equals x squared is kind of the moment when we have to deal with the exponent. So we're going to square root and square root. Square root of 28, not great. It's not like 25 or 64 or anything. So if we think about 4 times 7, 4 times 7 makes 28. 4 is 2 times 2. You have other ways to make this, but you will always get a pair of 2's and this poor singular 7 who doesn't have friends. Kind of like Mr. Johnson. 2 square root 7 is kind of how you coordinate those things. And then be careful, it isn't just x. That x is still trapped in the absolute value bars. Not a big deal to get rid of those. You just go ahead and you have the positive and the negative branch. So I like to scribble them out. That's my work. You just put a plus or a minus over there. So our final answer, since it's just x, and we don't have extra adding or subtracting or things like that, is positive 2 root 7 as well as negative 2 root 7. And if you write it out kind of slow like that, you can almost see the two answers that are there. These are two awful decimals. A lot of times our answers are going to be kind of like that. And if you're curious, you can always type it in 2 square root 7. And then 5.29 is going to be the positive of this. And then negative 5.29 will be the negative of this. That's all that changes. Very good. So we've been 20 minutes. I want to make sure that you guys have a chance to maybe practice this a little bit. I've done 4 of the harder questions. If I can ask you guys to maybe try your homework. And tomorrow, I'll probably go through the rest of these problems and make sure that you guys are all good with this concept. And we'll make sure that you're doing things in the right order. But you got to know kind of the steps, and you got to work backwards through PEMDAS. That is the biggest thing. Is you got to go from here and eventually deal with the exponent, and then you can get inside those parentheses and start back over and go through PEMDAS backwards again. So hope that helps. Let me know if you have questions. Be more than happy to clarify, and we'll do what's best for you guys, so probably not take a quiz tomorrow, but we'll have a chance to practice and work on things. Okay? So take care, everybody. I will see you tomorrow. Bye.